Hi, my name is Andreas Kiesel. I'm a bioinformatics researcher at the Institute for Biomedical Technologies at Bari, Italy. With this presentation, I would like to give you a short insight in a virtual machine we developed for teaching next-generation sequencing data analysis. The virtual machine is a tightly isolated software that runs its own operating system and application within a physical computer without interacting with the file system of the host machine. The virtual machine behaves like a physical computer, having CPUs, RAM, hard disk, network interface, and so on. The benefits of such a virtual machine is that these machines are compatible with all standard computers. It is an isolated machine, physically separated from the host. It encapsulates a complete computing environment, and it runs independently of the underlying hardware and operating system. The virtual machine we developed because we got asked to teach at places where we had no computing environment and we had very slow internet connection. We developed two virtual machines, one a 32-bit machine because in those days many of the users had only 32-bit machines, and of course a 64-bit machine because many of these NGS data analysis tools are optimized for 64 bits. Here you see the size of these machines when they are exported from the player. It's around 5 GB for the 32-bit machine and 14 GB of the 64-bit machine. Here you see the interface of the virtual machine before you start the machine up, and you see its physical properties. In this case, we were setting up a RAM of about 2 GB, 2 processors, and we have some external interaction with a floppy drive or CD-ROMs. You see we have graphical card and 2 ports for external hard drives. Our virtual machine we were building up on the Linux Ubuntu version 12.04. Here I just give you some idea what we installed on this virtual machine. So you see we have Apache 2 MySQL, BioPerl, then we have Emboss and the Vienna package, BLAST tools, R and Bioconductor, and some multi-sequence alignment tools. For the NGS data analysis, we have assembler like Velvet, SOAP de Novo, mappers like Bowtie, BWA, GMap, Max, Top Hat cufflinks, quality control tools like FastX Toolkit and the FastQC, and the famous SAM tools to deal with the SAM formatted file after mapping. Further, we have some visualization software for the mapping and assembly results like Tablet, Apollo, Artemis, and the graphical interfaces for NGS data analysis tools like Galaxy, and the visualization as browser, the famous GBrowse version 2. The way we were using this virtual machine, I was classifying in 3 levels. So the first level application is when we were installing the virtual machine on each participant's computer. Like this, every participant had his bioinformatic environment independent on his operating system and the physical properties of his machine. So it was able to set up accordingly the size of RAM and the number of CPU. But the advantage of this system, of course, was that every participant had exactly the same working environment and the teacher had exact idea what he is able to do. In this case, running the virtual machine on a personal computer, we of course had to adapt the size of the data. The big advantage in this level 1 application is that the virtual machine is installed on every participant's machine and he can bring this home and continue using it. This kind of level 1 application we were using, for example, in a master course in Mauritius, in a master course in the very northern part of Sweden, in a very remote place, and in other courses we gave in Africa, where we had very little hardware infrastructure. So the settings were kind of that we had personal computers with 1 or 2 CPUs, 2 to 4 gigabyte RAM. There were classes up to 30 participants, and we were playing with next generation sequencing data, single end sequencing of about 100,000 reads. We were doing quality control, assembly and mapping. Then we have the level 2 applications. Level 2 applications I call when I was installing the virtual machine on a small portable server. This is a big advantage when you have this virtual machine because it's a very little effort to install just the virtual machine on this server, and you have your bioinformatics platform. You put then the mini server in a local network and the participants can access via SSH or web services via HTTP like Galaxy or Gbrowse. And again, every participant had the same environment to work. In this case, he is mainly interacting with command line interaction. Also in this case, we had to adapt the size of the data set, and in this case, the participant doesn't have the virtual machine to bring home. Of course, we were offering that they can download the machine, but per se it's not installed on their machine. This system level 2 application we were using in a master course in Bari where we had 10 participants. So I had a mini-Mac with 4 CPUs and 16 GB RAM. We had 12 participants which were analyzing next generation sequencing data, which were pair-end reads, and we had about 2.5 million reads. And they were doing all in parallel assembly, mapping, and in this very specific case we were also running microRNA search algorithms. Then we have the level 3 application. Level 3 application is where we install the virtual machine on a computing farm. Again, with a little effort, we can create an entire bioinformatics platform. Again, via the local network, we can have access to the virtual machine via SSH or the web services, for example, for Galaxy and Gbrowse. Again, every participant, of course, has the same working environment, and according what resources you have available, you can deal with real data. This level 3 application we were using in 2 tutorials. We had one tutorial in Bari and one tutorial in Helsinki. We had around 40 participants for this tutorial. And according to the number of participants, then we decided how many virtual machines with which physical properties we were designing. For these tutorials, we were preparing 4 independent virtual machines, and each had 16 CPUs and 64 GB shared RAM. And we were able to analyze next generation sequencing data, single end in this case, with 2 million and more reads. In this very specific case, this was a course in microRNA searching with several mapping steps. These 40 participants were able to independently work on this virtual machine. The last improvement now on this machine is that we were implementing local websites for educational material. So every virtual machine hosts a website where we slowly, step by step, fill in the tutorials. In this case, you see there is a description of the data we get put on the machine, and you see step by step what the participant has to do. We have also graphical interface to data which the participants were producing. The future improvements we are working on is to get a smaller 64-bit virtual machine to have it easily downloaded for future applications. We of course would like to load much more educational material, and we would like to implement some more test data. We are also developing a dedicated website where then this virtual machine will be available for download. Thank you very much. This is my email address in case you're interested in having of one of these virtual machines we right now have, but soon you will find on this link here the final virtual machine we are right now developing. Thank you very much for your attention.